Well, here we are with one more identity, and we're asked to verify that the secant of x plus 1 over tangent of x is equal to the tangent of x over secant of x minus 1. And once again, the temptation here is to use the identities for secant of x are ratio identities, possibly for tangent of x, and so on. But that seems like an extra lot of work, right? Because we're going to be putting things in terms of cosine and sine and cosine when it's already in terms of tangent and secant. And there already is a relationship, a perfectly good one, between tangent and secant. So we might wonder, well, is there any way that we can use that to relate secant and tangent in this identity? Well, yeah, right? Think about it this way. If I have the square of the tangent of x, and I can draw that a little bit better here, the square of the tangent of x plus 1, I'm going to get the square of the secant of x, right? So I know this identity, and what can I say about this identity? Well, I could, if I wanted to, uh, subtract 1 from both sides and say, well, then the square of the tangent of x would be the same thing as the square of the secant of x minus 1, right? And recognizing that idea, right, we also have that related idea that, well, anytime we have a difference of two squares, we can factor it using that sum or difference binomials, a minus b times a plus b. Right? So there looks like there might be something here hidden in our expression and that we could probably use. And this kind of indicates to me that this is a Pythagorean trick kind of problem, a Pythagorean identity trick. So that's what I'm going to use. Remember that the trick that we did in an earlier example was that we multiplied one expression or the other on the left or the right by well, essentially a conjugate. So let's take this value on the right. I've got secant of x plus 1 in the numerator on the left-hand side over tangent of x. And I have tangent of x divided by secant of x minus 1 on the right. And so what I'm going to do on the right-hand side is I'm going to multiply the denominator by secant of x plus 1 in the numerator denominator. Remember, you can only manipulate one side of the expression or the other. Right? You can't multiply something to both sides to get rid of it. So we have to multiply on one side only. And in this case, noticing that we actually have an a minus b times a plus b situation will allow us to take advantage of this Pythagorean identity. Because, let's see what happens. Secant of x plus 1 over tangent of x. You'll notice, by the way, I keep writing one side or the other the same way as in the line above it. And I know that seems, oh, that's a lot of extra work, Professor Peoples. You're making us do extra work. I have to write it on both sides each time because you want to make us do extra work? Well, I'm sorry, yes, I do. Because this will help you keep organized. What are we aiming at? Well, on the numerator over here on the left, we've got the tangent of x times secant of x plus 1, right? You notice we've got a nice secant of x plus 1 on the other side. So let's just keep it as is. In the denominator, though, we're going to have the square of the secant of x minus 1. And as we showed above right here, this is the square of the tangent of x. So we get secant of x plus 1 divided by tangent of x. And that is equal to tangent of x now times secant of x plus 1 divided by the square of the tangent of x. And that was the good that that Pythagorean identity trick does us. We can now cancel a common factor of tangent of x. And so, yeah, we do have the expression that is the same on the left-hand side as on the right-hand side. I never had to change anything on the left-hand side of my equation. Right? I just kept on rewriting it the same way each time. And I'm left with secant of x plus 1 divided by tangent of x on the right-hand side. And so this verifies my identity, which is exactly what I was aiming to do. And so I'm done with this one.